Hey, what is up guys, Kotor here, and today I'm gonna be showing how actually the stack works in assembly x86 machine code. So some people are having a hard time understanding, and I decided to make a visual example, and of course also kind of show a little bit of how to call functions using the stack, how to push arguments using the stack instead of, just using registers. So you can see here there's two functions. There's two call operations here. One of them adds two numbers which are first pushed onto the stack, and the other prints an integer which is stored in the EAX register. And over here we have the add numbers function, which copies the first number, which is the argument 0, to the EAX register. As you can see, this is the actual stack right now. There's a 34-bit return location, 32-bit return location. Then there's the first argument, then there's the second argument. So it copies that right there, and then it adds the second argument to that same register, and then it returns with the result in the EAX register. Alright, so I'm gonna show a visual here of the actual stack. So the stack actually is a piece of memory, an address in memory, and it's usually stored in the ESP register. And an address might look like something like this. DF7, because in a 32-bit machine you have 1, 2, 3, 4, 5, 6. So you have 4 bytes here, which actually is the address where the stack pointer. So I can't remember what E is, but SP is the stack pointer. And let's say that this is the start of the stack. Okay, so every time you subtract 4, every time you subtract 4 from the stack, what you are doing here is actually moving the stack pointer, and you have these 4 bytes that you are now allocating in memory, because the stack grows backwards, right? So you have now these 4 bytes here, so 32-bit piece of memory, and the stack pointer actually moves. So the stack pointer, when you subtract, it actually now points to this location right here. And if you do that again, if you keep subtracting and subtracting, your stack is just gonna keep growing and growing and growing. Okay? So this is important. Okay. Why do we need to know this? Well, because if you're pushing something onto the stack, what you're doing is, okay, you're putting a value at the very end of the stack. So when we push 10, what it's actually going to do is going to take another piece of the stack, okay, and take that other piece of the stack, and it's going to write the number 15 in there. right there. And again, don't forget, this is 4 bytes. This is the 4 bytes. Every time you push aligned, when you push it aligned with the stack, because it's 32-bit, okay, that means it's 4 bytes. Each byte is 8-bit. So when I push 15, this is what the stack is going to look like, okay? And the stack pointer, again, is going to move. Now the stack pointer points over there because we pushed 15. And after we push up, I guess we pushed 10 and then 15. So, oh well, doesn't matter. Let's just push 10 now. So we're going to do the same exact thing. We're going to push another value onto the stack. We're going to take this memory, we're going to expand it by another 4 bytes. And we're going to put a new number in here, 10. Okay, I just need to fix this, it's a bit janky. Okay. And again, the stack pointer is now going to change. Okay, so now the stack pointer is going to point over here. Okay, so we push these values onto the stack. So far so good. But what happens when we try to call an actual function? Okay, well, if we go to the function here, you're going to see this here, return location. So actually what's going to happen is it's going to allocate yet another 4 bytes, alright? It's going to allocate it like this, alright? Now this is our return location, okay? And of course, the stack pointer now moves all the way over there. Okay? And so when you have that, you basically have this right here. Return location, argument 0, argument 1. Return location, argument 0, argument 1, and then the rest of the stack, alright? And of course we have our operations here. We move from the stack. This is ESP plus 0. Okay, this is ESP plus 4. Because remember, every single push is 4 bytes, okay? And this is in bytes. Okay, this is ESP plus 8. So okay, ESP plus 4, argument 0, we move it to EX register. And then we take the ESP plus 8 argument and we add it to the EAX register. And that is our function, effectively. So, after we're finished and after we return, the return location is automatically cleaned up. But we must still clean up these arguments because we're using the standard calling convention. So what we do is we add 8. And when you add 8, okay, so let's see here. First, it automatically cleans up the return location. Okay, no problem. So now the stack pointer actually points all the way over here. Okay, but when we actually add 8 to the ESP register, it actually erases these two. Well, it doesn't actually erase them, but basically it moves the stack pointer. You could say it erases them, but actually it doesn't really erase, like it doesn't actually affect the memory or anything. It just leaves it be, but it just moves the stack pointer. Alright, now we're back over here. Our memory, well, it's down the stack, like don't really have to worry about it anymore. Any other function or any other thing you do can just overwrite right over it. Doesn't really bother the actual CPU. that is the basic explanation for the stack that I have right now, and I hope that helps. Thanks for watching, stick around for more, and peace.